Hello friend, welcome to your channel, that is Civil Engineering Choice. And we know that already we have started the series for the reinforcement concrete structures, and we have covered one video uh, regarding the introductions of design of reinforced concrete structures. And today we are discussing about the second video, and that second video is also based on the introduction. Okay, so in today's video we will going to discuss about the six point video. Okay, so let's start with our sixth point, that is design philosophy of RCC structures. And I request everyone, if you have not refer my last video, so please go to that videos and see the basic contents that I have covered, or the introductions that I have covered for the RCC structure. And you can find that link in the description box. So just go through that videos, and then you can continue with this video. So design philosophies of RCC structure means how many philosophies, or we can say the how many methods are available for the design of reinforced cement concrete structures. That is an important thing, and we have to use that methods for the design of RCC structure. Means if you want to design any structure, RCC structures, already we have discussed how many structures are available in the. So here we have some methods like working stress method. Okay, that method is also called as allowable stress method, then ultimate load method, and the limit state method. So these are the methods that we are going to cover today for this video, and then we will proceed for how to design the member by using all these methods, and which method is important for the which structures, that also we are going to discuss in upcoming few videos. Okay, so now if we consider the first method, that is working stress method, that working stress method is also called as in short form WSM is a working stress method, and it's also known as allowable stress method called as ASD. Okay, so ASD and WSM method, both methods are called as a working stress method. So what is meant by working stress method? The working stress method is used for the design of reinforced concrete, steel and timber structure. Okay, basically that working stress method we can use for the design of reinforced concrete structure, design of steel and the timber structure. So for all these three structures we can use working stress method. The main assumptions in the working stress method is that the behavior of a structural material is restricted with the linear elastic region, and the safety of it is ensured by restricting the stresses coming on the member by working load. So in simple form we can say that when we are designing any member by using the working stress method, so in that case the structural material means whatever material we are using in that particular structure, that material should be in a linear elastic region. Okay, linear elastic region. So for that we must know the stress strain curve for the any material. Okay, stress strain curve for the concrete, stress strain curve for the elastic, and the stress strain curve for the RCC structure or the steel structure or the timber structures. Okay, so we must know the knowledge about that stress strain curve, linear, non-linear, okay, in elastic region, in plastic region, that we must know. And already we have covered some videos on that, so you can refer my videos which I have uploaded in the strength of material series. So you can check the stress strain curve I have uploaded over there. So you just go through that, and then you can come to know what is the stress strain curve. So here we are giving I am giving just short introduction. So generally what happens when we are applying the load on the any member, so we are calculating the elongation means we can consider it is strain. We are calculating the strain and the stress. Okay, and then we are plotting the graph to show the stress strain point. Okay, so up to the one point our stress is directly proportional to the strain. Up to the one point our stress is directly proportional to the strain. That point is called as an elastic point, and this region is called as a elastic region. Okay, when that graph or that line is straight or the linear, that's why we can say that is the linear elastic region. Okay, so in the working stress method, first we are designing our member in the elastic region only. Okay, and the safety of it's ensured by restricting the stresses coming in the member. Means when we are designing any member by using the working stress method, in that case we are calculating or we are focusing only on the stresses produced in the member. So this is the most important thing that we need to keep in mind while the designing of any member by using the working stress method. Again I am repeating second point. Second point is what? The structural element is restricted in the linear region only. Okay, we are designing it only in the linear elastic region, and when we are designing that member, we are focusing on the stresses produced in the member. Okay, then if you see the next third point is what? Thus, the allowable stress will come in a linear portion, that is, initial phase of the stress strain curve. Thus, the factor of safety was introduced to the design. Factor of safety is the ratio of strength of material to the permissible stress. Okay, when we are designing any member by using working stress method, so that member we are considering in a elastic region. So that's why we can say the factor of safety for such type of member, we can say factor of safety is equals to strength of material. Okay, it is equals to strength of that material to the permissible strength, to the permissible strength. Okay, to the permissible strength. Okay, so this formula we can consider to calculate factor of safety, or to consider the factor of safety. Basically, for the design of any member, what we are considering? We are considering the actual strength of member, and then we are comparing that actual strength to the permissible strength. Actual strength means what? The strength which is produced due to the actual loading and the end conditions of the beam, that called as a actual strength, or we can, in simple form, we can say the strength is produced due to the actual loading. And the permissible strength is what? Permissible strength is what? It is a allowable strength. Okay, and that allowable strength we can calculate as per the codal provision. Okay, in the code some provisions are given, so on that basis we can consider the permissible strength, and that permissible strength is depend on the every material. So when we are designing any member by using the working stress method, so the formula for the factor of safety is what? Actual strength divided by the permissible strength. Then next, the fourth point is when we consider the effect of creep, shrinkage, strain concentrations, and the other secondary effects, the assumptions of the material behavior in the elastic range will not hold. This will lead the increase of stresses into the inelastic range. Okay, so basically what happens? Whatever the strain, creep, shrinkage that are developed in the member, that uh, assumptions is not considered in the design of working stress method. That's why whatever the stresses produced in the inelastic range, that stresses are the very high zone. So that is the, we can say, the disadvantage of working stress method. And if you go with the working stress method is totally depend on the stresses produced in the member. That's why we require the large size of any element. Okay, then fifth point is WSM means working stress method is still being using in a special structure such as water tank, chimneys in India. Okay, and the elastic region hold good in serviceability check such as a crack width and the deflection. Okay, so basically we know that the working stress method, if we use the working stress method, so as we discuss now, in the working stress method we will get the higher side, because whatever secondary effects are there like shrinkage, creep, and the stresses, that secondary effects are not in elastic zone, not considering in the elastic zone. So that's why the stresses are producing in a elastic range. Okay, but still in some structure we are using the working stress method, like water tank, chimneys. Okay, in India generally we are using working stress method to design the water tank, chimneys, and all other structures also there, that we will discuss one by one. Okay, so again we are using the same, we are using the working stress method for the design of such type of member. Okay, then once we discuss the working stress method, next is the ultimate load method. So what is the next in the ultimate load method? This is known as load factor method or the ultimate strength method. In this we make use a non-linear region of the stress strain curve of steel and concrete. Okay, so basically why we called this method as the ultimate load method? Because we are doing the factor load, we are considering the factor load or the ultimate load for the design of our member. And basically for the design of steel, concrete, or any member, we are considering the non-linear region for the design purpose. Okay, so in working stress method we are using only linear region or the linear portion, but in ultimate load method we are going in the non-linear zone also. Okay, so that is the advantage of ultimate load method over the working stress method. The next, The safety is ensured by introducing the load factor. The load factor is the ratio of ultimate strain to the service load. Okay. Now load factor, factor of safety formula is what? Factor of safety is equals to ultimate load. Okay. Ultimate load, ultimate load divided by service load. Okay. Divided by service load, or that service load is also called as a working load. Okay. Working load. Now see, in previously in working stress method we have focus on the strength. Okay. We have focus on the strength, means that factor of safety is based on the strength. Okay. But now in the ultimate load method, we our factor of safety is depend on the load. Okay. So that is different, the main difference between these two methods, working stress method and the ultimate load method. And name is also suggests load method means we are considering the load factors for the design point of view. Then ultimate load method makes it possible to consider the effect of different loads acting simultaneously, thus solving the shortcoming of the working stress method. Okay. So basically what happens, if number of loads are coming on the member, so in the working limit state method we can use or we can consider that different loads simultaneously for the design of any member, and basically that thing we are not doing in the working stress method. Okay. So that is, we can say, the main advantage of ultimate load method over the working stress method. Okay. Then next, as the ultimate strength of the material is considered, we will get such a slender section for a column and beams compared to working stress method. Okay. Again, previously we have discussed that when we are going to design our any element by using the working stress method, so we will get the higher size of members. Okay. But if we use this ultimate strength or the ultimate load method, so we will get slender sections, means the size of beam, column or any element will reduce as compared to the working stress method. Okay. But what is the uh, weak point of that ultimate load method? But the serviceability criteria is not met because of large deflection and crack in the section. Okay. But in the working ultimate load method, we are not, means they are not considering the serviceability criteria, means they are not focusing on the deflection of the member and the cracks develop in the section. So this is, we can see, the weak point of the ultimate load method. Okay. Then next, the fallback in the method was that even through the non-linear stress strain behavior of was considered the section, but the non-linear analysis of the structural was not carried out for the load effects. Okay, so basically what happened, we are using the non-linear stress strain curve for the design, or non-linear stress strain behavior for the design of the any section, but non-linear analysis of the structure is not carried out. Okay, means non-linear analysis we are not considering for the design point of view. So this is, we can say, big point of the ultimate load ultimate load method. Now the next one is the limit state method. This philosophy is an advancement over the traditional design philosophies. Okay, means whatever design philosophies we have seen in last few slides, like working stress method and the ultimate load method, so this is the advancement of the limit state method. Okay. Ultimate load method, that is the first thing. The second is what, it considered the safety at the ultimate load and the serviceability at the working load, the short of extension of the working stress and the ultimate load method. So generally for the design point of view, okay, for the design point of view, in the limit state method we are considering the ultimate load as well as the serviceability. Okay, so both we are considering for the design of member, when for the design of member by limit state method. So that is most important thing for the design of any member. Okay, the limit state is the state of impending failure beyond which a structure cases up perform its intended functions satisfactorily in terms of either safety or the serviceability. In short, what if we use the limit state method, so that limit state method give the satisfactory results for the safety as well as serviceability. For both conditions, limit state method is most important or the most efficient or most economical as compared to the working stress method and the limit state method. Now see just a summary of all the working stress method, ultimate load method, and the limit state method. So if we consider working stress method, okay, so I'm just giving the important point. In working stress method, we are using only elastic region, okay, only elastic region we are considering. Then second, we are using the strength or the stresses for the design point of view, okay, and then then we will get higher size, okay, then we will get the higher sizes. That is work in working stress method. When we go with the ultimate load method, in ultimate load method we are using inelastic region, okay, in elastic region we are considering, okay, non-linear we can say. We are focusing on the ultimate load, okay, we are focusing on the ultimate load, and then the sizes are less, okay, less size required as compared to the working stress method, okay, less size is required as compared to the working stress method. And and the limitation is what he is not going to consider, not consider the deflection, okay, not focus on the deflection. And if you go with the limit state method, so in limit state method we can use this method in the elastic region, okay. So in elastic region we are considering load is also ultimate over here, okay, the load is ultimate. Then obviously we will get the less size as compared to the working stress method, okay. Yes, and the important thing is whatever deflection is produced in the member, that deflection can be considered in the limit state method, okay. So if we see over here, the limit state method is the most economical or the most usable method uh, for the design of any member. And recently every member we are designing by using this limit state method, so that is most important thing. So the one next one is what the there are two types of limit states, okay, basically two types of limit states that we are considering. First is the ultimate limit state and the serviceability limit state. So in the ultimate limit state we are focusing on the strain, overturning parameters, fatigue, slidings, etc, okay. We are in limit state method we are considering strength, overturning, fatigues, and the sliding parameter etc that we are considering in the limit state method. And and in the serviceability we are focusing on the crack width, deflection, and the vibration. It means what, if we go with the limit state method, then the strength as well as the deflection, both parameter we can consider, okay, both parameter can be considered in the limit state method. That's why in most of the cases we are using limit state method for the design purpose, okay. The basic requirement of design is what, first safety, means if you want to design any type of structure, so these are the basic points that we need to keep in mind for the design of any member. First is safety, the structure should be safety, okay. Then serviceability, means whatever deflection and whatever additional portions are there, okay, that should be resist, okay, the serviceability should be good. Then durability, the structure should have the durable, means structure should have the maximum life period. Economy, general, obviously if we are designing any member, so that should be economical. So these are the parameters that we need to keep in mind. So main parameter we can say that we can keep in mind for the design of any member, okay, any member, or we can say the any type of member. So like it is steel member, RCC member, timber member, any member we can, if you want to design, so we need to keep these four parameters, basic parameters, for the design purpose, okay. Now the next again important point for the exam point of view is what, the comparison between the working stress method and the limit stress method. So the summary of the working stress method comparison, okay, summary of comparison between working stress method and limit stress method already we have discussed, okay. But now we will go with the some points which are really important for the design point of view or the comparison point of view. This method means working stress method based on elastic theory, which assumes that the concrete and steel are inelastic and the stress strain curve linear for both, okay. Means when we are designing steel or concrete structure or the RCC structure, any structure with the working stress method, so that material is in elastic region and the stress strain curve we are considering a linear zone up to the linear. Okay, but when we are considering the limit state method, the actual stress strain curve of the steel and concrete, and for the concrete, the stress strain curve is non-linear. So here we can consider the stress strain curve non-linear, and actual behavior of that stress strain curve for the any material like steel or concrete, that we are going to consider in the limit state method. The next one is, in this method, factor of safety are applicable. Okay, factor of safety are applicable the yield stresses to get a permissible stresses. Okay, and in this method, the factor of safety or the partial safety factors are applied to get the design value of stresses. Okay, means when we are considering the factor of safety in the working stress method, we are focusing on the yield stress only. Okay, to get the permissible stress. And when we are considering any member as per the limit state method, so in that case we are going to consider the stresses. Okay, now next, no factor of safety is for the load. Okay, in working stress method we are focusing on the stresses. That's why we are not using any factor of safety for the load in the working stress method. And in the limit state method, the design load are obtained by multiplying the partial safety factors of a load to the working load. Okay, means generally what happen in limit state method, we are considering the ultimate load. Okay, we are considering ultimate load, and that ultimate load we can get with the factor of safety, means factor of safety multiplied by working load. Okay, by using this formula. Okay, generally we are using this formula, uh, ultimate load. Okay, ultimate load is equals to factor of safety into working load. Okay, into working load. So we can use this formula to calculate ultimate load method, to calculate the ultimate load in the limit state method. Then this method gives thicker section, so less economical. Okay, obviously already we have discussed, we will get the maximum sizes in the working stress method. That's why it is not economical. In limit state method, we can convert that structure in economical, because we will get the thinner section. Okay, in the sizes of sections we can get reduced in the limit state method. This method assumes that the actual loads, permissible stress, and the factor of safety are known, so it is called as deterministic method. Okay, now in working stress method, the actual load, whatever actual load coming on the structure, that we know, the no actual load we can know, permissible stress is also known over there, and the factor of safety is also known in the working stress method. That's why we can say that that method is a deterministic method. Okay, but the limit state method is based on the probabilistic approach, which depend on the actual data. Hence it is called as non-determinate method. So basically, in working stress method we are focusing on the probabilistics, means probability values we are considering, and it's basically depend on the actual data. So we can say that this method is a non-determinate method. Okay, so these are the general comparison between working stress method and the limit state method. Okay, so hope you understood all the things. So again I am repeating it. So we are planning to upload all the types of all the subjects which are related to the structural engineering, like engineering mechanics, strength of material, structural analysis, design of reinforced concrete structure, design of steel structures, and also we are focusing on to upload some more videos or the content which are really important for the field point of view. So if you are really getting knowledge from these videos, please like and subscribe my channel, and click on the bell icon so you will get notification. Okay, so I request everyone, please like and subscribe. Thank you so much for the patience. Thank you.